let's go ahead and get started. So good morning, everyone. This session is sipping sake, creating a build and release pipeline for PowerShell. So let's get started. A little bit about me. My name is Brandon Olin. I am a SRE at Stack Overflow. Hopefully everyone here has used Stack Overflow and has gotten some value out of it. I am also a Microsoft MVP in Cloud and Data Center Management, and I am Dev Black Ops on pretty much most of the internet, so Twitter, GitHub, Slack, that's probably where you can find me. So before we start about Saki, I want to talk a little bit about what is a task runner. So that's what Saki is. Task runners, as you can probably guess, run tasks. In the case of PowerShell, we're talking about running script blocks, and if we're, taking script blocks and running them, you're going to probably think, well, that's kind of what a function does. And you're right, but tasks behave a little bit differently than just normal PowerShell functions. Can do some extra things, can also not do some things that functions can do, but they're useful in certain circumstances. For one, tasks can have dependencies on other tasks. So if I want to run task, in this case, task E, task E has a dependency on running task C and D. Task C has a dependency on running task B, et cetera. So if I wanted to run task E, I got to run its dependent tasks first before that task executes. And this is the, usually these tasks run once. Once they're run, they don't run again. So if task, in this case, task E had a direct dependency on B, and also task C had a dependency on B, B would only execute one time. It's not going to run every time, although sometimes that is exactly what you want, and that is configurable. But also, when tasks fail, usually the whole sequence of tasks fails. And this is useful in a pipeline of sorts where I'm running a series of steps, and once things fail, I want to stop at that step because it doesn't make sense to continue on to do other things. And why would you want to run these task runners? We want to automate everything that we're doing as far as PowerShell development. They offer a way to standardize the way these things are executed when you're building modules or testing them or deploying them. They also have, like I said earlier, a notion of dependency management, so I can define a task and also define, okay, well, if I want to build a module, I should probably compile it, or if I want to test it, I need to build it. If I need to publish it, I probably should build it and test it and then publish it. Don't want to publish it, right after, without testing it, things like that. So you want to ensure that these dependent tasks execute before you can go on to other steps. One big thing is that they also allow portability between different CI tools. So if I'm running, a build process for a PowerShell module in things like Azure Pipelines, I could use the built-in tasks in Azure Pipelines, but I'm also tying myself to Azure Pipelines. And that may be something you're okay with, maybe you're not okay with that. But using these external task runners gives you a notion of portability. With that portability, it also allows you to run these things locally on your machine before they go into your CI process. So I can, build and test a module locally, then commit it into the CI process and have it execute this exact same way over there, and be assured that it's going to run the same thing. And ultimately, what we want to do here is don't repeat yourself. You want to define all these steps, not have to duplicate a lot of code, and have the same process run locally, have the same process run in CI or on anyone else's machine. You can rest assured that this is operating exactly the way you expect. And also, this is my hot take about build and test processes, that they should execute the same way on your machine as on anyone else's machine or any other CI process. So this is my personal opinion on not relying so much on these built-in tasks that Azure Pipelines will offer you to build a module, test it, and publish it, or deploy Azure website or something like that. I personally like to put this stuff in code in Sake, which I'll show you in a little bit, because then I can run it locally, or I could take the same process and run it in Travis. I could take the same thing and run it in TeamCity, GitLab Actions, which I'll show you a little bit later as well, without any really code changes whatsoever. But that's my personal opinion. Take it with a grain of salt. Before I talk about PSAKE specifically, though, I want to talk about some other task runners that you probably have heard of. All of these have the notion of running tasks, dependencies, a series of steps. Some of them do more than others. MS Build does a whole bunch of stuff besides just running tasks. But you'll hear these, often if you're looking at JavaScript code or C# code or Java stuff. You're going to see Ant, you're going to see make files, cake, Gradle, Grunt, invoke build, which is another PowerShell task runner similar to PSAKE, rake for Ruby. So if you see these, just know that they basically are doing the same, the same thing, just in their language of choice. They all have their own little specialties, and some of them have limitations that others don't. But just know that they're basically doing the same thing. So let's get right into PSAKE itself. It is a build automation tool written in PowerShell. Originally, it was created in 2008, so it's almost as old as PowerShell itself. It's been around for quite a while, by James Kovacs. It is pronounced PSAKE, not PSAKE or PSAKE or some other weird pronunciation. It is sake, like the Japanese rice wine. It has had many maintainers over the years. It's been around for quite a while. I am the current Red Pirate Roberts. As a couple of years ago, this was a project that was needing a maintainer, and I offered up my hands, and I'll take it. But that doesn't mean that I may be the maintainer forever. Maybe someone in this room will want to take it over at some point if I want to move on to other things. And that would be awesome too. If people also want to contribute to this, it's totally open to do that. So let's talk a little bit about PSAKE commands before I actually show you a little bit of the code. Externally to PSAKE, it's really basic. It has two commands: invoke PSAKE and get PSAKE script tasks. And they kind of do what you expect them to do. Invoke PSAKE will actually just run the task runner, run whatever tasks that you've handed it. Get PSAKE script task will list the available tasks from that script file. Internally to PSAKE, the PSAKE file that I'll show you in a second will have a lot more. Ultimately, these are functions, but this is kind of a DSL within PSAKE. DSL is domain-specific language. But at the end of the day, all of these things here are really just PowerShell functions that operate a certain way. But inside PSAKE, you'll see tasks, which are the actual little nuggets of code that will execute whatever automation you want. So at the end of the day, a task is basically a named script block and maybe some other metadata about, this is the code to actually deploy a module, this is the code to run PS Script Analyzer, this is the code that run Pester, et cetera. Properties is a function that you can put at the top of your PSAKE file to define some initial variables that you wanted to set for your build environment. And there's various ways to run those or change them, which I can show you. Assert is a helper function to basically run an if-else statement and say, I'm going to assert that this statement is true, and if it's not, I'm going to throw an error. And it's just basically a helper function. So if I want to, make some assumptions that this environment variable is set or this folder is there, and if it's not there, I just want to bomb out. It'll basically just throw a terminated error, and that would tell PSAKE to stop. But it's not required. It's just a little helper utility. Exec is another function that that is really useful when you're executing external binaries. So what it does is it will execute that binary and watch the exit code that binary returns. And if it's not 0, it'll assume failure and throw a terminated error that will tell PSAKE that something is wrong in the task and to stop. Task setup and task teardown are other functions that you can run to have some startup and tear down scripts that run at the end or the beginning of PSAKE and at the end of PSAKE, maybe for some initialization or some cleanup processes. Include is a little used function, but that's a PSAKE specific way to import modules. I'm not really going to talk about it because I don't think it's used anymore. It's kind of a legacy function. Framework is also, it's a little bit rare to use the framework function when you're talking specifically about PowerShell, because what this does is it it attempts to find where MS Build is. If you're doing C# development and you have multiple versions of MS Build on your machine, Framework will figure out what version you want to run and put that in your path, so you can just run MS Build without doing the full path to the specific MS Build function. It's pretty specific to C#, which I'm not going to go into in this presentation. And then format task name is a way so you can, when Saki runs, it'll display each task running. You can color that, or you can, display that task in a certain way, so you can kind of it stands out when you get a giant wall of text. So some pretty common tasks that you're going to probably build or see in other people's projects when you're talking about PowerShell development is these right here. And this is how I laid them out to kind of show you the dependencies of them as well. And also split them out into primary and secondary tasks. So when you're talking about PowerShell development, you're probably talking about I need to build that module in some way. Maybe I need to take all the, one of the common ways to lay out PowerShell modules now is to do a private and public folder, put all your script files in those, and then dot source them in the PSM1. Some people don't like that because it can tend to slow down the modules on import. So when we talk about building in PowerShell, what we sometimes mean is actually just taking all those public and private functions and concatenate them into the PSM1 file. So you have a giant PSM1 file, when you build the module and publish it, but when you're actually putting it in source code, it's all laid out and structured, well organized. So that's your build process. And you could do lots of other things like pulling in dependencies from other things. You would also want to test your module. Ideally, you're testing your module after you've built it. Some people can flip these around and will tend to test the source files of their module and then build it and then ship that and then run into issues because you have not technically tested what you've built, what you've actually published. That build process could put some unintended side effects into your process that you may miss if you reverse those steps. And then publish, obviously we're going to publish to the PowerShell gallery or publish to an internal NuGet feed or put on a file server or whatever publish means in your case. Those secondary tasks are things that need to happen related to those primary ones. Like I said, the test, if I want to test a module, what I could mean is I actually need to run PS script analyzer, I need to run pester, I need to do task X, Y, and Z, and all of those encompassing things, that makes up what I call test. So I can run a test task and have it actually depend on 4 or 5 other tasks that will get executed automatically for me. And the same thing with build. I've split out the build process into actually building the PowerShell module itself, but also dealing with PowerShell help. So when I take the comment-based help from my functions, I can run platypus and create markdown files from those, take those markdown files, create the god-awful mammal XML file, and put that in your PowerShell module. You can automate all of those steps, but separate them into discrete tasks. Maybe you also would clean the output directory before you actually want to build a module, and things like that. And very way down at the bottom here, init. Maybe you would have your build process needs to install some dependencies. So think about how your build process would work if I was going to run it in Azure Pipelines on a hosted pool where I don't directly control the dependencies that are on that module, that are on that build server. So Microsoft will provide a build agent that has probably MS Build, that'll have PowerShell. It probably has pester. I don't think it has platypus. I don't think it has build helpers. I don't, all these other helper modules, which I'll show here. So if I need to install those as part of my build process, I need to make sure that they're there. That's something that you can do in the init process. So anytime I start any task as part of my build process, the first thing that gets run is the init stage, which actually installs all of my dependencies. And I'll show you a little bit about what that will look like as well right now in the demo.
Version control, how do you handle that?
The answer is Git. always good. But hold that thought, and I'll answer it in a little bit. So here in Demo 1 is a sample module that I've written that doesn't do much of anything useful, but kind of shows you the layout of, at least the way I like to write PowerShell modules, where I have the actual root folder is Demo 1. I have a subfolder, which is the actual code for the module, but I also have, other scaffolding type files like my build script, my PSAKE file. I can talk about PS_depend if no one has heard about that, but that's a module by Warren Frame that you can define dependencies and have them get installed as part of your build process. But these are related files to the module, but they're not core to the module itself. So my PSAKE file is a fair amount of code here where I'm going to define a properties block, and I'm going to set up some variables that I'm going to use throughout the rest of the tasks. So I want to say, what is the current directory? What is the directory that I'm going to test? What is the directory where I'm going to output my built module? What is the directory where my pester tests are? What my PowerShell version is. If I'm trying to be a good citizen and make this cross-platform, what my path separator is, because that can be different depending on Mac, Linux, Windows. So I want to make that generic. And then I'm going to define a bunch of tasks. So task default is basically the unnamed task that PSAKE requires, and it's going to, if I just ran PSAKE and gave it the path of the PSAKE file without a task name, it's going to run the default task. My default task has a dependency on test. So if I just run my build script, which will execute PSAKE without a task named, it'll just run the default, which is the test, and the test has a bunch of other dependencies, which kicks off the whole chain. Before I jump in a little bit further, I wanted to show the build script. So what I like to do in all my projects is have this build script, and this is the entry point into everything here. So it's really its job is to get PSAKE on your machine if you don't have it, and then run PSAKE. So if I can take this repo, run it on a vanilla machine, if I've done it correctly, it'll install all the dependencies it needs automatically and just run. So you don't have to go and backtrack and look in the code and say, oh, okay, well, I'm missing pester because I got a pester error, or script analyzer is not on it. What this will do is if I run this bootstrap switch, it will install PS_depend from the PowerShell gallery if it's not available, run PS_depend. PS_depend is where I define all my requirements for my build stages. So if I look at this requirements file, I require build helpers, pester, platypus, PSAKE, script analyzer, and I can define the versions of those. So my build script is just the entry point into everything. And once I bootstrap all of that stuff, I can run invoke PSAKE, pass it the file that I'm going to run. Any task that I've specified by default, it'll be the default task. So if I just run build, it'll just run. Let's go back into the PSAKE script a little bit. So I have my test task, which is the one that executed. The test task actually doesn't run any code itself. It just is a wrapper to other dependencies, which is init, analyzed, pester, etc. My analyze task depends on build. I shouldn't analyze my source files. I'm going to analyze what I actually built at the end of the day. And all of this code here is essentially just running script analyzer, taking the result object from script analyzer, seeing if I had any errors. If I do have an error, throw an error. Something's wrong. Or if I have some warnings, maybe I'll display those. My pester task will also depend on the build process, and we'll basically cd into the output directory, import the module, run the tests, export the NUnit XML, look at any failed tests in pester. If I have anything that failed, throw an error, stop the build. And create markdown help, update markdown help. I won't go into these in too much detail, but these are tasks that will convert comment-based help from your PowerShell functions into markdown, convert that markdown into the MAML file for your output for your built module. Your publish tasks will basically just run one command to publish your module. Again, you can't publish until you test, hopefully. Clean will just clean an output directory. Compile, quote unquote compile. We're not really compiling anything in PowerShell, but we're basically just concatenating all of your source, public and private file scripts into the one giant PSM1. And this is something you may want to do if you have a lot of public or private functions in your module and you don't want to dot source. Some people have experienced extreme load delays of a module when you're dot sourcing. But it's really a pretty poor development experience to manage a 10,000 line PSM1 file, unless you really hate yourself. So I ran that build process, and I can also run a help, and I can list at the end of the, internally this is running get PS script tasks to see all the tasks that I can run. I can choose which one to run, which dependencies they have. I can run the pester task, and you can see here that that actually ran a init, which just shows me some output variables. It ran clean, compile, markdown, build, pester, and then nothing else. But I've actually ran the build process correctly. It ran a init, clean, compile, markdown, and then build, but not test or pester or script analyzer. It also output that module into this out folder. So this is now your complete module, which then you can choose to publish or test. And you can see here in this PSM1 file that I have my my public and private functions here loaded directly into the PSM1. But if you actually looked at my source files, I had them separated out into private and public folders, and my PSM1 was basically just empty. So that's PSAKE in a very quick level, and it's a good way to define all the build processes for your PowerShell. But that was a lot of code that we repeat in every single project that we write, every single module. And I do this, or I used to do this, and I don't anymore since I wrote this, what I'm about to show you. But I have a lot of PowerShell modules, and typically when I start a new module, I probably copy my other module that I just wrote and tweak something, and then I do another one, and I copy that one, and I copy that one, and then have you ever seen like multiplicity, where you do copies of copies of copies? Yeah, so you know where that's going. So all of your modules start behaving just a little bit differently. So what I introduced recently in PSAKE is the concept of shared tasks. And what this does is it reduces the boilerplate code of the PSAKE file that you're going to repeat in every single module and centralize this. And you can standardize this across all your PowerShell projects. And ultimately what this is going to do is it's going to improve the quality of your build process because it's going to be the same for everything. Also, this is a public, open source module on the PowerShell gallery, which anyone can use. So everyone here who writes modules doesn't have to basically reinvent the wheel and come up with their own way to run pester, their own way to run script analyzer, publish, and everyone is just doing it a little bit differently. So this module is a way to have everyone basically use the same thing. And this is called PowerShell Build, and this is where you can find it. And what PowerShell Build essentially is a set of PSAKE tasks that are bundled in a PowerShell module that your PSAKE file in your project can pull from. So you don't have to come up with your own way to do a test and pester and analyze and build, and it's all there in PowerShell Build. And if you conform to the kind of the standard way that more and more people are writing PowerShell modules, it just works. It comes with its own tasks to do init, clean, build, analyze, pester, markdown, help, etc. Publish. And so let's take a look at that real quick. Okay. So again, this is the same module with a public and private folder. I have some other files in here which you may or may not have in your PowerShell project. So if you're using VS Code, you may have some VS Code tasks and settings. You may have a README file. You may have a changelog if you're doing semantic versioning. You may have a code of conduct, a markdown file if this is an open source project and you want to kind of lay out how this project is going to govern itself. You have a license file that maybe say you're MIT or Apache. You have a README file, you have a requirements file. You have a lot of these extra files. But PowerShell build doesn't help with that specifically, but it does help with your SAKE file. So in SAKE 4.8.0, which was officially released last week, I added the ability to say, run a task, but get it from this module and optionally this version of that module. So I want to say, run the test task from the PowerShell build module, specifically version 0.3.0. So let's see what that does. So if I'm going to run the test task, it ran the init, the clean stage, create the markdown, build, help, pester, analyze, etc. Test. Looks like I have some script analyzer warnings. But I didn't have to write any of that itself. All of that was bundled in the PowerShell build module. And oops, I'll show you right here real quick. This is the GitHub repo, and there is a ton of other settings you can do that govern how you want these tasks to behave. So maybe I want to change the output format for pester, or I want to disable or enable script analysis. I want to actually do pester code coverage. You can turn that on. You can change your default locale. You can change what the PowerShell repository that if you're gonna publish this, you can change that to something else. All of these are defined as variables which you can change, but you don't actually have to modify the code directly. It's written in a way that'll take these all in and adjust its behavior at runtime. So if I want to say, I have a module here with public and private. I got my private and public functions. I have my PSM1, and I dot source them in. But for whatever reason, people are complaining about performance, and they really want me to compile all this stuff into the single PSM1. I can turn this on. Say, okay, compile the module, so take all the public and private things and insert them into the PSM1. And I will uncomment, or comment this out. Oops. Run my build. And now if I look at my output directory, I have all of that concatenated into my PSM1 automatically. And you notice it also created the help, so it created the god-awful and mammal file, which you should never ever see and modify directly. So that's PowerShell build in a nutshell. It's essentially just a set of shared SAKE tasks that you can run. You can do that same type of behavior if you're doing SAKE for other things. You can create a PowerShell module that has your shared tasks to execute things that are not even PowerShell related. What I do is I run SAKE tasks to deploy and test Terraform modules, and those have a set of SAKE tasks to orchestrate all that, deploy Terraform, test, make sure it, run pester to make sure what I created match what I think it should be, times 20 different Terraform modules, and then you're duplicating SAKE tests every single time. So you can bundle all that logic into a single PowerShell module and then just have it called. So that saves a lot of time. So that was PowerShell build. But there is still a ton of non-PowerShell in our PowerShell project. And I'm sorry to say that is okay, that's for your own good. If you're doing high quality PowerShell modules, you're going to have markdown files and PSD1 files and pester files and everything is, all of those non-PowerShell things to help your PowerShell project. So to help with that, if you're going to create PowerShell modules with all of this extra scaffolding, I created another project called Stucco, which is a opinionated plaster template, and I'll go over what plaster is. Plaster is a PowerShell module that's essentially a templating engine. So I can create a bunch of template files and put some and do some string interpolation. So I can take all these text files, run it against Plaster, maybe pass in some parameters. It will replace tokens in those text files with whatever I deem necessary, and create output a fully formed text file with all those variables replaced. So Plaster itself has a fairly basic PowerShell template. Stucco is my opinionated way to do PowerShell modules. So it's what I do for all of my projects. So I create, a licensing file. I create a change log, code of conduct file, read the docs if you want it. Platypus support, PSDepend, PSAKE, App-A or Azure Pipeline support, GitHub issue templates, NPR templates, VS Code tasks. So all of this you could do yourself, but again, you're running the same thing if you're originally with PSAKE is that I take a PowerShell project that has all this set up, and I basically just copy and paste and tweak for every single module, and then they start to drift. So Stucco is a way to codify that all in one place, and then so when I create a module, I run Stucco and I just create exactly how I want it to look. So let's take a look at that real quick. Stucco is a PowerShell module you can get on the gallery, and once you import it and once you have Plaster installed, you can go get a template. And what that did basically was inspect all my PowerShell modules, looking for things that look like they have Plaster templates in them, return them, and I'm going to filter just to the one for the Stucco module. And then I'm going to execute Plaster. So I'm going to create a new project in my current directory, and I'm going to say this is my awesome module. That is important, thank you. That would have been bad. Okay. And we'll create, this is a demo. We'll say this is version 1.0.0. And it'll inspect your Git config and try to determine your username. What type of license do I want? I'm going to say MIT, and I'll just accept the default. Do I want a code of conduct? Yes, you should. Create an email address that will get inserted into that code of conduct. I'm not going to do Markdown support, or sorry, MKDoc support. I'm not going to do classes. I do want Platypus support, and I do want to say I want to do Azure Pipelines, and it will create everything for you. So now I have a fully built module, stubbed out, that has my public and private folders. I have my PSM1, my PSD1, Azure Pipelines is wired up, changelog, everything to kind of support like a healthy, fully high quality module. And also I can just say build, and it will just go and build it. And I did include some helper pester tests to test your, mainly what these do is they test that you have a valid module manifest, and also that you've done comment-based help for every single public function in your module. So you have a pretty good head start of just creating a project from the get-go by using that. So that is Stucco. I encourage everyone here, if you like to build modules, check these out: PSAKE, PowerShell build, Stucco. Especially if you're writing a lot of modules, it's going to really kind of save you a lot of time to do all this scaffolding stuff. Before you actually even get down to what you really want to do is just write your actual PowerShell code. All of this stuff is like your vegetables. This is stuff that you really should have, but you just kind of avoid. So I'm trying to make it easier for everyone. You can also do the tasks. Why isn't that working? Task. Oh, come on, VS Code. Okay, never mind. I do. It's in my demo. Well, maybe that's true. Maybe at the root, because I'm not technically at the root. But you have your VS Code task here. defined, so you can just run those as well. And ultimately what these end up doing is just running your build script. Like I said, everything is executed from that build script. You also have your GitHub issue templates. If you decide to put this on GitHub, if someone creates a new issue, if you don't know how to, what about issue templates is that this is meta documents that you can put in a GitHub repository to say every time someone creates a new issue, it'll just come up with this block of text. So you can kind of standardize when people create issues, they fill out this essentially a form. So you can when people create issues, they all kind of look the same. You know, they're not. You can kind of encourage people to insert the information that you want, so you can actually troubleshoot their issue. If you can do a pull request, a template, issue template, you can also when someone wants to contribute, you can do a contributing markdown file. They can read this and show you what the proper process is for your project on how to contribute back. So if they want to add more cowbell, this is how you would write that in a Git commit message for your project. So that is Stucco. All right. GitHub Actions. This is a pretty cool, another way to do more than just CI/CD, but a lot of people are playing with it for CI/CD. GitHub has a beta right now of a way to execute tasks inside Docker files right inside GitHub, so I don't need to mess with Azure pipelines or AppVeyor. It's a way to execute just arbitrary tasks in response to events that happen on your project. So not just committing code, you can actually have GitHub Actions execute when someone creates an issue or a pull request or even stars of a project. You can have some code execute to do something. Maybe you want to have something on a schedule to look at your current GitHub issues and mark them as stale if there's been no activity in 90 days or something like that. So it's an interesting way to execute just various things in GitHub without having to go outside GitHub and install extra bots or wire up other services. So with GitHub Actions, if anyone here is in the beta or lucky enough to get in the beta, they can play with this. Hopefully sometime this year this will become a public, they'll release this GA. But I created a GitHub action to execute your PSAKE tasks, so you can just have your full CI/CD process 100% within GitHub without wiring up to Azure pipelines if you don't want to. And I'll show you what that is, how that looks real quick. So a demo for. So here's another repository, my little playground to test GitHub Actions. GitHub Actions, it's a similar structure to a PSAKE file or any other task file. You're going to define actions to execute and what they depend on, what arguments you can pass to them, how they get triggered. In this case, when a push happens to a GitHub repository, meaning some code is committed, I want to execute the publish task. Or action. I'm going to probably screw that up many times. Your publish action will have a dependency on the docs publish task, and your docs publish task or action, could have dependencies on docs.gen and analyze, and just like PSAKE, you could have tasks or actions depend on other ones. And the way actions work is that you can actually point to a GitHub repository that has a Docker file, and GitHub will take that Docker file, build it, and execute the code that you've told it to, and run your action inside a sandbox essentially with your code available to it. So this is a really nice way for the community. And if you actually look at GitHub Actions, there's a lot of stuff out there you can do with it already. But people have built these actions that have Terraform in there, or they have npm, or they have all these other utilities where you can run these actions with their code baked in. And you don't have to worry about that. You just say, I just want to run this action, and I don't have to worry about installing Terraform or npm or getting my build server perfectly configured. You can just run these in these little isolated containers. So I created an action to execute PSAKE. So let's go ahead and make a change and commit it. So this is something you should never do, is have a plain text password. We'll push that up. Did that go? Okay. And let's look at my GitHub Action Playground. I'll look at, and if you're in the beta, you'll see this Actions tab, and you'll see my workflow being executed. And it's already executing, and what these are going to do is run my GitHub action, which actually internally just runs PSAKE tasks. And within a minute or so, hopefully, the analyze task will detect, because that's running script analyzer, that I have a plain text password in there, and it should fail the process. So that is GitHub Actions. If you want to play with it, I would encourage you to sign up for the beta. I have no clue when they're actually going to make a GA, but hopefully this year. And you can see my init ran, and I actually look at the log file. You can see that this is actually just pulling a Docker file here, building it, and right here it's actually running PSAKE. Because it's beta, it's a little flaky. Doesn't always refresh all the time. So my build ran, now I'm generating my docs and I'm running my analyze. Hopefully within a second or two, that will fail. Oops, sorry. So let's talk about a little bit about good practices for sort of PowerShell development. I said this earlier, build, then test, not test, then build. Especially if you're just doing a public and private folder with dot sourcing, oftentimes you can, Pester will load up your module, test it, and then you run your build process after the fact to generate your help files or do some extra, some post tasks, and then you publish it. Well, you may not realize what you're doing there is actually just publishing something that you technically have not tested, and there's an opportunity there to insert some bugs. You also want to test your help documentation, and this is what Stucco will do: is it inserts some some Pester tests, is making sure that your public functions in your module actually have comment-based help. It's like you have a synopsis, you have a description, you actually have at least one example for every single function, and that just helps. For me, that helps me, at least write some token documentation for my project. You also want to test those examples to make sure that they're valid. Oftentimes, and I've done this too, create a module, write some examples, edit the module, evolve it over time, and now my examples are no good anymore. So testing is cheap, and do it often. And also use a build tool if you want to, or you can just ignore everything I've said and just do it all straight PowerShell. That is totally cool as well, as long as you're following the basic processes. That's really all I ask. But we want to remove all the manual steps for all this stuff. So if you want to build a lot of projects, automate all this boilerplate code away, automate all this toil away as well. So that's all I have. Thank you again. My name is Brandon Olin, Stack Overflow. You can find me on Dev Black Ops on the internet. And if you have any questions after this, I'm happy to answer them. So, thank you.